Hello, this is Mr. Best. Welcome to Chapter 7, homework questions 140 to 146. 140. Each problem below gives the endpoints of a segment. Find the coordinates of the midpoint of the segment. If you need help, consult the math notes box for this lesson. So, a couple different ways you can do this. If you need to plot the points, you can do that. What we want to do is we want to find the total distance between the x values. So 11 and 5, the total distance is 6. And you can also do that by subtracting the two numbers. So the total distance 6. So then if I divide that by 2, then the total distance between 5 and 11 would then be, to the midpoint would be 3. So therefore, if I add 3 onto 5, I get 8. And then for the y value, you can do the same thing. 14 minus 2 is equal to 12. And then if you take half of that, that is 6. So if I add 6 onto 2, then that would be 8. So that would be your midpoint. 3 and 8, 3 comma 8 and 10 comma 4, same thing. So if I'm looking at my x, I'll take 10 minus 3, and that's equal to 7. Half of that is 3.5. So therefore, if I add 3.5 onto 3, that puts me at 6.5. For the y value, we have 8 and 4, so 8 minus 4 is 4. Half of 4 is 2. So if I add 2 on or subtract 2 to 8, either way, it doesn't matter. Just as long as you go in between 4 and 8, that would be 6. Question 141. Below are the coordinates of 3 points in the equations of 2 lines. For each line, determine which of the points, if any, lie on that line. There may be more than one. Alright, so for the first equation, y equals 1/3 x plus 15. We can take those points and we can plug them in as one way to figure out if they're on there or not. So for example, x 0 comma 15, that would be 15 is equal to 1/3 times 0 plus 15. And that does represent the y-intercept, which you can also see. So that would be a point. So yes, the point x 0 comma 15, that works. What about 3/16? So 16 is equal to 1/3 times 3 plus 15. So 16 is equal to 1 plus 15. And so once again, you can see that one works as well. So the point y 3 comma 16 works. And then we'll do z, which is 7 comma 0. And you might be able to recognize that one is not going to work pretty quickly. You have 1/3 times 7 plus 15. So you're adding two positive numbers, so there's no way that one's going to work. So z does not work, just x and y. And then for part B, we have y minus 16 is equal to negative 4 times x minus 3. I'm going to simplify this equation. Don't have to, but might make it a little bit easier to plug in the information. So make sure when you distribute the negative 4 that you do have a negative 4 times negative 3, which is a positive 12. And then we add 16, so we get y equals negative 4x plus 28. So let's start with 0, 15. And once again, we'll see pretty quickly on this one that that is not going to work because that's not the y-intercept. So x does not work. Next one, 3 comma 16. So 16 equals negative 4 times 3 plus 28. So negative 12 plus 28 is equal to 16. So the point y at 3 comma 16 works. And then 7 comma 0, we have 7 is equal to negative 4. Oh wait, nope, got those switched around. 0 is equal to negative 4 times 7 plus 28. 0 is equal to negative 28 plus 28. So that one does work. So the point z, which is 7 comma 0, works. And since y works for both of them, that would be the intersection of the two lines. And so that would actually be the solution to that linear system. Question 142. Must be, could be. There are some, here are some more challenges from Mr. Quincy. For each description of a quadrilateral below, say what special type of quadrilateral must be or what special type of quadrilateral could be. Look out, some descriptions may have no musts and some descriptions may have many coulds. So in part A, my quadrilateral has 2 right angles. So is there a must statement? If it has two right angles, must it be something? You might think a rectangle, but that's not true because you could have two right angles in a trapezoid. So it looks like must be, there's not one thing it must be, but there's a couple things that it could be, as we already stated. It could be, if we're being specific about the type of trapezoid, it could be a right trapezoid, could be a rectangle, and then it could also be a square. B, the diagonals of my quadrilateral are perpendicular. So once again, diagonals of the quadrilateral must be perpendicular. Might need to go back to your toolkit to take a look at that. But once again, on this one, there's a couple things it could be, but there's none that it must be. So it could be, once again, what is it? The diagonals are perpendicular. It could be a kite. It could be a rhombus. And then it could be a square. Question 143, examine the arrow diagram below. Polygon is a parallelogram, then the area of the polygon equals the base times the height. So once again, polygon is a parallelogram, then the area of the polygon equals the base times the height. So part A, write this conjecture as a if-then statement. So we would just say the first part, if a polygon is a parallelogram, then, which is kind of that, then its area equals its base times its height. For part B, it wants us to write the converse of this statement, and then is the converse true? So converse, remember, we switched the order. So if the area of the polygon is the base times its height, then the polygon is a parallelogram. So we're just going to switch the order of those. And then the second part of the statement wants to know, is the converse a true statement? So if the area of the polygon is base times its height, then the polygon is a parallelogram. And yes, that is a true statement. Part C, write a similar conjecture about triangles. Write it once as a conditional statement and once as an arrow diagram. All right, so for a triangle, we could say if a polygon is a triangle, then its area equals 1/2 its base times its height. And so that's part C. And then it also wants to do an arrow diagram, but it's going to look exactly the same as this part up here. So just repeat that. And then on part D, write the converse of your triangle conjecture from part C. Is the converse true? So once again, we'll just switch it. If a polygon's area is 1/2 its base times its height, then the polygon is a triangle. And once again, that will always be true as well. And so there's that last statement. And once again, the converse is true as well. Question 144. The angle created by a hinged mirror when forming a regular polygon is called a central angle. For example, angle ABC in the diagram below is the central angle of a regular hexagon. Part A. If the central angle of a regular polygon measures 18 degrees, how many sides does the polygon have? Now remember, a full rotation or a full circle here is 360 degrees. So on part A, if we want to know how many sides it has, we can take 360 degrees and divide it by 18 degrees, and that will give us how many sides it has, which in this case would be 20 sides to the regular polygon. Part B, can a central angle measure have 90 degrees, 180 degrees, 13 degrees for each angle measure? Explain how you know. So for 90 degrees, if you take 360 degrees and divide it by 90 degrees, that would give you 4 sides, which would be a square, so that works. If you take 360 degrees and divide it by 180 degrees, that would be 2 sides, and that does not work because you need 3 sides to close in the figure there, so that one doesn't work. And then 13 degrees, 360 degrees divided by 13 degrees is approximately 27 point, whatever sides. Well, that doesn't make any sense. You're not going to have 27 point something sides, so therefore 13 degrees does not work. So the only one that works on this one is 90 degrees, and that gives you a total of 4 sides for that one. So this one doesn't work also. Question 145. Jamaica designed a game that allows some people to win money and others to lose money. But overall, Jamaica will neither win nor lose money. So once again, to read that sentence again, allows some people to win money, but others need to lose money. But overall, she will neither win nor lose money. Each player will spin the spinner below and will win the amount of money shown in the result. How much should each player pay to spin the spinner? Explain your reasoning. So what we're looking for is the expected value. How much do we expect each player to win over time? So the $3 is 1/4 of the spinner. The $1 is 3/4 of the spinner. So our expected value is 3 times 1/4 plus 1 times 3/4. And that will be 0.75 plus 0.75. So $1.50 is the expected value. So how much is Jamaica going to charge each player to pay if she is neither going to win nor lose any money? And so she would charge $1.50 per spin. And that will ensure her over a long period of time that she should be breaking even. Question 146. Suppose ADBC is a quadrilateral and the diagonal AB lies on the line y equals negative 4/3 x plus 5. So let's just stop right there. Let's go ahead and graph negative 4/3 x plus 5. So we got to go down 4 over 3. Down 4 to the right, 3 would be a negative. Or we can go up 4, which is positive, and to the left, 3 would be negative. So we'll figure out in a second, but there's that line, and that will be the diagonal of the quadrilateral. And then there's another diagonal, CD, that lies on this line. So let's figure out where that line is. Negative 1 is the y-intercept with a slope of 3/4, so up 3 over 4. Up 3 over 4. So we also go down 3 into the right or left 4. All right, and once again, remember these are the diagonals of the quadrilateral. All right. And assume the diagonals intersect at point E. So somewhere in there it looks like they're going to intersect at point E. A, without graphing, what is the relationship between the diagonals? How do you know? Well, I guess I should have read the problem first before graphing. I didn't graph the quadrilateral, though. I just graphed the diagonals. So without graphing, what is the relationship between the diagonals? Well, what you're going to notice, hopefully, and I didn't need to graph this to see this, but the slope on the first one is negative 4/3, and the one on the second one is a positive 3/4. So those are opposite reciprocal each other, so the relationship between the diagonals is that they are perpendicular. So we can do that without the graph. We didn't need the graph to do that. So we know that the diagonals are perpendicular. And we know that because their slopes are opposite reciprocal. All right, on part B, graph the lines on graph paper. Okay, and now I did that. If E is a midpoint of CD, what type of quadrilateral would ADBC be? Is there more than one possible type, and explain how you know? All right, so once again, B wants us to graph the lines. Just to verify, E is the midpoint of CD, so CD is somewhere. We don't, once again, know exactly where these points are located, but CD, and somewhere over here we're going to have A and B. I just spread them out because, once again, I don't know exactly where they are. But E would definitely be the midpoint, it says. And then what type? Well, think about what we have. We know the diagonals are perpendicular, so that leads us to, we have a kite, a rhombus, a square. So those are the three, and then they also, there's one more piece here, is that since E is the midpoint of CD, that it does also bisect one of them. And a kite, that's what happens. Otherwise, the kite would have had to go away if it was both of them. So a kite, there's only one diagonal that bisects another.